Hello, welcome back. We're doing Chapter 1, Section 8, Exploring Transformations. Page 63, we're working on problems 8, 9, and 10. Just like the previous practice problems where we were doing translations and reflections, for this one we're going to do stretches and compressions. But the process is going to be the same. Hopefully by seeing it over and over again, you're starting to see what the process is. I'm going to do a horizontal stretch by a factor of 3, and it looks like I might be off the grid just a little bit, but it'll be okay. Alright, so for this really weird looking graph that looks like an M but's got these little wings at it, it's usually best if I pick the vertices, and there's 5 of them, and then I like to pick more points for things that go off the grid so I can see what direction they're going. So I'm going to pick this one and that one. Looks like there's going to be some symmetry with this, but we'll see how that goes. So I'm going to make my table. I've got 7 points, so I'm going to need to make my table big. Negative 4, 1. Negative 3, 0. Negative 1, 2. 0, 1. 1, 2. 3, 0. And finally 4, 1. Extend that down just a little bit. The new graph is going to be a horizontal stretch by a factor of 3. Let's look at the table. So horizontal stretch tells me I'm going to multiply the x by a number. The number that I'm going to use is going to be 3. So my b is going to be 3. And my rule is going to be 3 times x. So I'm going to make a new table, my new x, which actually is 3 times that x. I would have written 3x, but I think that causes more problems than it saves. So when I wrote this with like the original and new, hopefully that keeps them straight for you. Okay? So I'm not changing the y, so I'm going to rewrite all the y values. 1, 2, 0, 1. I'm going to multiply each of these by 3. So negative 4 times 3 is going to be negative 12. Alright, I already know that's going to be way off my graph. Here's negative 4, so negative 12 is going to be over here someplace, okay? That's fine. Don't panic. That is nothing to panic about, right? Negative 3 times 3 is negative 9, same idea. Negative 1 times 3 is negative 3. 0 times 3 is 0. 1 times 3, 3 times 3, and 4 times 3. Alright, so I'll do my best with drawing what the graph is going to look like, but I'm going to have to assume some of it just because of the grid that I've given myself. So first of all, 0, 1 stays where it's at. Remember, if I'm going to stretch it sideways, I'm going to pull it away this way, anything that's on the y-axis is going to stay where it's at. So that one stays there. Negative 3, 2 and 3, 2 are going to go here and here. What that means is that that point got pulled over 3 times as far. That point got pulled away from the y-axis 3 times as far. Negative 9, 0, here's negative 5, negative 6, negative 7, negative 8, negative 9. So that one's going to be way over here. So that point got pulled over away from the y-axis that far. Positive 9, 0, here's 4, 5, 6, 7, 8, 9. It's off my grid over there. And the negative 12 and 12, negative 12, 1 and 12, 1, that's going to be even further. I'll show you how that's going to look. But I've done enough. To be honest, just making a table is all you really need to do. This is going to get stretched to look like that. This part right here is going to get stretched to look, I'll do my best, to look like that. And then the other part is actually going to get stretched and it's going to go that direction. I'll put the arrow on it. This part right here gets pulled over that way. This part right here gets stretched this way. And then also I'm going to have something doing that. So look at the red graph. Just focus on the red. Now look at the green. what happened to the red graph was that I grabbed every point and I pulled them apart away from the y-axis. So now it looks, I mean, honestly, it looks like it's not flatter because the y values didn't change, but because I stretched it out horizontally, it looks wider, if that makes sense. There's some technical issues with that, but I think that kind of helps you understand what's going on with that. All right, let's see what happens with problem number 9. Problem number 9, I'm going to do a vertical stretch by a factor of 3. So I'm going to start off the same way. Here's my, and you know what? I'm using my tables and I'm writing them vertically. I could have written my tables horizontally. I seriously don't care about that. I still got -4, 1, -3, 0, -1, 2, 0, 1, 1, 2, 3, 0, and 4, 1. That's still this point, that point, that point, all of these here at the vertices, and plus these two on the end to tell me what direction they're going. Let's talk about a vertical stretch by a factor of 3. Vertical stretch tells me that the y value is going to be multiplied. So my a is going to be 3. And again, this may go off the graph, it may not, you know, I may be able to graph part of it, but that's not a big deal. So my new table, all of my x's are going to be the same. So -4, -3, -1, 0, 1, 3, 4. But I'm going to multiply each of these y values by 3. So 1 times 3 is 3. 3 times 0 is 0. 3 times 2 is 6. 3 times 1 is 3. 3 times 2 is 6. 3 times 0 is 0. And 3 times 1 is 3. I'm going to plot those. So -4, 3 is right here. -3, 0 stays where it's at. -1, 6. Let's see, here's 2, 3, 4, 5, 6. So that one's going to be off the graph just a little bit. 0, 3 is right here. 1, 6, 3, 0 stays there. And 4, 3 goes right here. Now, before you panic, because that may not help you connect the dots, look at the red graph that we already have. This point and this point stay where they're at because they're on the x-axis. Since I'm stretching vertically, anything on the x-axis stays where it's at. So this left part here now looks like this. This second part of the segment, which is kind of at an angle, is now going to go up this way. And if you follow the rest of it, just like that. So if you look at the red part, I grabbed every point on the red part and I stretched it up 3 times as high. Last problem. Same graph. I'm going to do what I told you I was going to do last time. I'm just going to make my table horizontal. That doesn't mean anything at all. Okay? So here's my x's, here's my y's. I get -4, 1, -3, 0, -1, 2, 0, 1, 1, 2, 3, 0, and 4, 1. Okay, I just wrote the table horizontally. That doesn't change anything. For the new function, I'm going to do a vertical compression by a factor of 1/3. So let's go back. Vertical compression, I'm still going to multiply the y by something, but this time 1/3 is bigger than 0, but it's less than 1, so that's why it's going to be a compression. Okay? So, my x's are all going to stay the same. And I'm just going to divide each of these by 3. Again, you can use decimals, but don't. Decimals are just kind of like you waving a flag saying, I'm using a calculator. 1 divided by 3 is just 1/3. That's all you got to write. 0 divided by 3 is 0. 2 divided by 3 is 2/3. 1 divided by 3 is 1/3 again. And I get 2/3, 0, and 1/3. One more time. And I'm just going to estimate. So -4 1/3 is about right there. It's less than half, so I know I made it really thick so you can see it, so it's not perfect. -3 0 is still going to be right here. -1 2/3 is going to be about right here. And I'm going to finish the rest of them off just like that. I know you can plot points. And this looks like that. So just like in problem number 9 where everything got stretched above it, this got compressed. This is where everything is getting stretched. This is where everything is getting compressed. Hopefully you guys can see that. Okay, so that's the stretches and compressions. We'll be back with more problems in just a moment.